So today what we're going to do is we're going to finish our section 1.2, which we started talking about, which is about functions and models. Before I pick up where we left off, let me just do a quick review of everything we discussed. So remember, our goal in this section is to learn more about functions and ways to represent real life situations. So we talked about what a mathematical model is. Particularly, it's a way to represent real life situations in mathematical terms. We went through the example that says the amount of free space left on your hard drive is now 50 gigabytes and it's decreasing by 5 gigabytes per month. Find a mathematical model for this situation. So here we said, okay, let x be the time in months and let f of x represent the space on your hard drive. A mathematical model for this specific situation, because we said we have 50 gigabytes left on the hard drive and it was decreasing by 5 gigabytes per month, we came up with the mathematical model 50 minus 5x. Okay? Now, the next part of this example says my rectangular cabbage patch has a total area of 100 square feet. Find its perimeter in terms of the width x. Now, we drew a rectangle, we knew the width was x, and we labeled the length as y. We know that the area is the length times the width, so we have 100 is equal to x times y. We also know the perimeter of a rectangle is the sum of all its sides, so that's 2x plus 2y. Now, the problem says find its perimeter in terms of the width x. So that means that we do not need a y here. We want everything on this side in terms of x. So what that means is we need to go back up here using our area equation, solve for y. We get y is equal to 100 divided by x. And then we substitute that in here to get p of x, which is now our perimeter in terms of x, is equal to 2x plus 2 times 100 divided by x, or that's equal to 2x plus 200 over x. Okay? Then we moved on and then we introduced some terminology. We want to talk about cost, revenue, and the profit functions. A cost function specifies the cost C as a function of the number of items x. Thus, C of x is the cost of x items and has the form cost is equal to your variable cost plus your fixed cost. The variable cost is a function of x, and the fixed cost is a constant. Okay, so a linear cost function, we hear the word linear, we think of line. This is a cost function of the form c of x equals mx plus b. Note that mx is a function of x, so that is our variable cost. B is a constant, which means it is our fixed cost. The slope, m, in front of the variable x, that's our marginal cost. And what the marginal cost does is it measures the incremental cost per item. The revenue, or net sales, resulting from one or more business transactions is the total income received. If R of x is the revenue from selling x items at a price m each, then R of x is the linear function R of x equals mx. So in other words, the selling price m is also called our marginal revenue. Remember, the m is what's in front of the x, so that is our marginal revenue. The profit, or sometimes called the net income, is what we have left when costs are subtracted. If the profit depends linearly on the number of items, the slope m will be called your marginal profit. A fact which is something that you will need to remember, know, and know how to apply it. We relate profit, revenue, and cost by the following formula. Your profit is equal to your revenue minus your cost. And terminology that you should be aware of, if your profit is negative, we refer to it as a loss. To make neither a profit nor a loss is what we say is breaking even. So that means that either your profit is equal to 0 or your revenue is equal to your cost. The break-even point is the number of items x at which break even occurs. Okay, so now that we have all of this terminology, what we wanted to do was we wanted to go through an example. So we went through the following example 2. It says the cost of renting tuxes for the Choral Society's formal is $20 down plus $88 per tux. We want to, in this example, express the cost C as a function of X, the number of tuxedos rented, and use your function to answer the following questions. So here, we notice that, hey, we're going to put $20 down, which means that's not going to change. That's going to be fixed. Well, if that's fixed, that means that that is our constant or our fixed cost. So we know we're going to add 20. Okay, and now we're going to say $88 per tux. So that means that our cost function C of X is going to be equal to 88X plus 20. Okay, and right here we just wrote down the general form of the cost function. Now, we went through parts A through D. We answered, what is the cost of renting 2 tuxes? Well, that means we need to take 2, substitute 2 into our cost function C of X to find 88 times 2 plus 20 is equal to $196. So that means that the cost of renting 2 tuxes would be $196. Now, I asked, what is the cost of the second tux? Well, that's $88 as well. Why is that $88? Because remember, you put the $20 down initially, okay? And you do not have to put that down every time you get another tux. So that's why you have here, it's just $88. Now, what is the cost of the 4,098 tux? That's $88 too, okay? It's just kind of a trick question. What is the variable cost? The variable cost, remember, is a function of X. So looking back up at our function, we see that is 88X. What is the fixed cost? Remember, we put $20 down. That never changed. So our fixed cost is 20. Now, what is the marginal cost? The marginal cost is equal to 88. The marginal cost, remember, is the slope or the coefficient of our X. Okay? Now that we have all of that, let's go through another example. This is where we are now picking up where we left off. The Audubon Society at Enormous State University is planning its annual fundraising eat-a-thon. The society will charge 50 cents per serving of pasta. The only expenses the society will incur are the cost of the pasta, estimated at 15 cents per serving, and the $350 cost of renting the facility for the evening. Okay, so in this first part, we are asked to find C of X, which is our cost function, R of X, which is our revenue, and P of X, which is our profit. Okay, so let's jump right in and let's make some observations. So notice, remember, C of X in general has the form mx plus b, and for us, we need to identify m and b. So for us, m, which is our marginal cost, is 15 cents per serving. So we look back, it says the only expenses the society will incur are the cost of the pasta, which is estimated at 15 cents per serving, and the $350 cost of renting the facility for the evening. So that's the fixed cost here. Okay, so that 350 will be B, but our marginal cost is the 15 cents. Okay, and our fixed cost is the $350 it costs to actually rent the facility. So putting that together, we get our equation for our cost function is 0.15x plus 350. We are also asked to find our revenue, and whenever we look at our revenue, we see that, hey, we read back our problem. It says the society will charge 50 cents per serving of pasta. So that means our revenue will be 0.50x or 0.5x. And our profit, remember, is our revenue minus our cost. So that's equal to 0.50x minus the quantity, 0.15x plus 350, because this is our cost. And we distribute the negative, so we have 0.50x minus 0.15x minus 350. So that gives us the equation 0.35x minus 350. Okay, so that's our profit equation. Now, in part B, the question says, how many servings of pasta must the Audubon Society sell in order to break even? Well, what does it mean for them to break even? For them to break even, that means our profit has to be zero, or in other words, our revenue has to be our cost. So take a minute, pause the video, and try it. That means our profit is equal to zero. So pause the video and try it, and then come back. Now, that means 0.35x minus 350 is equal to 0. Or in other words, 0.35x is equal to 350. Divide both sides of this equation by 0.35, and that gives us x is equal to 350 over 0.35, or in other words, we have 1,000 servings. So in other words, that means, to interpret our answer, that means that the society has to sell 1,000 servings in order to break even. In part C, it says what profit or loss results from the sale of 1,500 servings of pasta. Well, based on C, if we sell 1,000 servings to break even, that means that part C, if we sell 1,500, that means we should be making a profit. But let's check. We need to substitute 1,500 in for x into our profit equation, which, remember, our profit equation is right here. Okay, so we get that's equal to 0.35 times 1,500 minus 350. That gives us 525 minus 350, which is equal to 175. So that means we make the society, not us, the society would make $175 profit. Okay, now there's another concept that you need to make sure you understand, and it has the same idea as everything we've discussed so far. It's demand, supply, and equilibrium price. Make sure you read about this on pages 69 to 71 of your books, and watch the video that I posted in Blackboard, which provides an example on demand, supply, and equilibrium price. Now, let's go ahead and talk about compound interest. Okay, if an amount P, called the present value, is invested for T years at an annual rate of R, and if the interest is compounded or reinvested in times per year, then the future value A, is given by the equation A of T equals P times the quantity 1 plus R divided by N raised to the N times T. Okay, this is an important equation. You'll want to remember it. you will have to apply it and know it. The interest compounded once a year is given by the following equation. Remember, the n represents the times per year. And if it's compounded once a year, then what we're going to do is substitute n equals 1 into this equation just to write down what our equation should be. So A of t should be equal to P times the quantity 1 plus R raised to the t, because remember n is 1. So R would be divided by 1, which is just R, and n times t, n is 1, so that means we should just get t. Okay, perfect. Now let's go through some examples. Okay, so example 4. In August 2013, Ally Bank was offering 0.61% interest on its online savings account with interest reinvested daily. We are going to find, in part A, the associated exponential model for the value of a $4,000 deposit after T years. Okay, here, this is just asking for the equation. It didn't ask us to find anything else. Part A is saying find the associated exponential model for the value of a $4,000 deposit after T years. So remember our equation that we just talked about. A of T is equal to P times the quantity 1 plus R divided by N raised to the T times N. Now, it says T years. Okay, so we have that. Now, it says we are finding the exponential model for the value of a $4,000 deposit. So what that means is we know P is equal to 4,000. So we know that. But now the question is, what is R and what is N? So let's read our problem again. It says Ally Bank was offering 0.61% interest. That means R is 0.61%. So R is 0.61%. But remember, we have to take into account that we are dealing with a percent. So we take inside, we write 1 plus 0.0061, because remember, percent means you take what you have and divide it by 100. And then we say we're dividing it by n. Well, remember, n is the number of times per year, but it turns out for this specific problem, it says the interest is reinvested daily, right? How many days are there in a year? 365. So n for us is 365. So we divide 0.0061 by 365, and then we raise that to 365t. Okay, so this is our model. This is our model. Okay, and part B says, assuming that this rate of return continued for 8 years, how much would a deposit of $4,000 in August 2013 be worth in August 2021? An answer to the nearest dollar. Well, now this means that T is equal to 8. So now T is equal to 2021 minus 2013, which is 8. So we find A of 8. We get that's 4,000 times 1 plus 0.0061 divided by 365. All of that raised to the 365 times 8. Now, I expect you to at least be able to write down this line, okay? And once you write down that line, you can then use your calculators. Substitute that into your calculators. Wavy equals means approximately, so that means approximately. We get $4,200. Okay, so that's how much it will be worth in August 2021. A couple of notes to make. Compound interest is an example of exponential growth. and that's a quantity whose magnitude is an increasing exponential function of time. A quantity whose magnitude is a decreasing exponential function of time is called exponential decay. An example of exponential decay is the decay, that's a C, decay of unstable radioactive isotopes. Okay? Awesome. So now let's look at another example. The amount of carbon-14 remaining in a sample that originally contained A grams is given by the equation C of T equals A times the quantity 0.999879 raised to the T, where T is the time in years. We can rewrite the formula above as A of T equals, so in other words, we can solve this equation for A by dividing by this, and we get A of T is equal to C divided by 0.999879 raised to the T, or another way of rewriting this is A of T equals C times the quantity 0.999879 raised to the negative T. Okay, so we're using an algebraic rule there to go from here to here. Now, a fossil contains 4.06 grams of carbon-14. Using A of T, estimate the amount of carbon-14 in the sample 10,000 years ago, 20,000 years ago, and 30,000 years ago. So we're asked to do 3 different things, but it helps for us to realize for this problem, it says a fossil contains 4.06 grams of carbon-14. So what that means is that means C is equal to 4.06. We can make that a little bit better. 0.6. Here we go. And we know that A of T is equal to 4.06. We're using smiley face up here. So that's 4.06 times the quantity 0.999879 raised to the negative T. Now, of course, you'll be using your calculators for this problem. Okay? Now, the first thing we're asked to find is A of 10,000. So that's equal to 4.06 times the quantity 0.999879 raised to the negative T. So this means negative 10,000. Substitute that into your calculators, evaluate it, and it's approximately 13.6 grams. So that's what we get as the amount of carbon-14 in that sample of 4.06 grams of carbon-14 after 10,000 years. Okay? Now we need to find A of 20,000, and we need to find A of 30,000. A of 20,000 is 4.06 times 0.999879 raised to the negative 20,000, and that's approximately 45.7 grams. All right, now we need to find A of 30,000. Well, that's 4.06 times 0.999879 raised to the negative 30,000. And that is approximately, once you enter it into your calculators, you should pause your videos and try these for yourself, of course. And once you do, you should get 153 grams. Okay, awesome. So that tells us that the amount of carbon-14 in the sample of 4.06 grams of carbon-14 after 30,000 years is 153 grams. Okay, Now, we want to talk about the algebra of functions. Now, this just says, okay, if you are given two functions, you can add them. So if f and g, let me not make random marks. If f and g are real valued functions of the real variable x, then we can add them. So f plus g of x is equal to f of x plus g of x. That's called our sum. We can subtract them. F minus g of x is equal to f of x minus g of x. That's our difference. We can multiply them. So f times g of x is equal to f of x times g of x. That's our product. And we can divide them. F divided by g of x is equal to f of x over g of x. This is called our quotient. A couple of facts here. The domain of the first three, which is the sum, difference, and product, it's all real numbers x that are both in the domains of f and the domain of g. The domain of f divided by g, our quotient, is a little bit different. It's all real numbers x that are simultaneously, or both at the same time, are in the domains of f and g, provided that g of x is not equal to 0. And we have to exclude this one because we cannot divide by 0 here. So now let's look at an example where we are going to apply this. So given g of x is equal to x minus 1 with domain negative infinity to infinity, and f of x equals x squared plus 1 with the domain negative infinity to infinity, we're going to find the difference, g minus f of x, and we're going to specify its value at the given point a equals negative 1. Okay, so g minus f of x is equal to g of x minus f of x. That's just applying the rule. And that's equal to g of x is x minus 1. So we're taking that and putting it there. And then we're going to subtract f of x. F of x is x squared plus 1. But remember to put that in parentheses, right? Because it's more than one term, so we have to be careful with the sign that is in front, which is the negative. So we get x minus 1 minus x squared minus 1 because we have to distribute the negative. And that gives us negative x squared plus x minus 2. Good. So we found g minus f of x. Now, when x is equal to negative 1, that just means we need to find, or a is equal to negative 1. You can put x there if you want to. Same thing. Now you need to find g minus f of 1. Doesn't mean multiply them, it means substitute. So we're finding negative 1, not just 1. So let's make that correction here. So that should be negative 1. So that's equal to, using smiley face here, so that's equal to negative times the quantity negative 1 squared plus a negative 1 minus 2. Well, negative 1 squared is 1, but that negative is hanging on the outside right here. So this is equal to negative 1 minus 2. Or in other words, we get negative 4. That's it. And now part B says, what is the domain of g minus f? Well, we look back at our fact. It says that the domain of the sum or difference or product is all real numbers x that are both in the domains of f and g. Well, we know that the domain of x minus 1 is all real numbers. The domain of f of x is all real numbers. So that means that the domain of the difference, according to fact 1, the domain is all real numbers as well. And in interval notation, that's what we write. Okay? Perfect. Remember that the domain of a quotient is all real numbers x simultaneously in the domains of f and g, such that g of x is not equal to 0. Okay? Now, our last example, let's look at a quotient problem. So remember so here we're given g of x, but now it looks a little different. G of x is x minus 1 with domain negative infinity to infinity, and v of x is equal to the square root of 10 minus x with domain the closed interval 0 to 10. Okay, we want to write a formula for the quotient g over v of x. So that's equal to g of x divided by v of x, and that's equal to x minus 1 divided by the square root of 10 minus x. So this is our formula. Now we have to give the domain of this equation, or that formula. It's not an equation, this formula. Well, to give the domain of the formula, we need to know that, or we know from the previous page, the domain is all numbers in negative infinity to infinity and the closed interval 0 to 10 such that the square root of 10 minus x is not equal to 0. Well, we say the square root of 10 minus x is not equal to 0 because we cannot divide by 0 here. So that means that if we figure out or solve this, that means that we have, if we take the square of both sides, that means we have 10 minus x cannot equal 0, or that gives us 10 cannot equal x. So the domain, since we have, it has to be all numbers in the real numbers and the closed interval 0 to 10 such that x does not equal to 10. That just tells us that our domain would be the closed interval, well, not the closed interval, the interval that includes 0 and goes out to 10 but does not include 10. So that would be our answer. So if you need to review that, remember that the domain is all numbers that are in both the function on the domains of the function in the numerator, the domain of the function of the denominator, but we have to exclude the number that makes our denominator 0. You may have more than one, but here it's only 10. And there you go. Now we have to specify its value at the given point x equals 1. So in other words, part C is asking us to find g over v of 1, and that's equal to, now we're going to use, call everything smiley face. We're going to use that. So we get 1 minus 1 divided by the square root of 10 minus 1. That's equal to 0 over 9. 0 over the square root of 9, be careful. 0 over 3, which is just 0. That's it. So that concludes sections 1.2.